Hey guys, today I'm going to go over your study guide. Remember, these videos are a little bit different. You can skip around to the questions that you need help with, but make sure that you completed your study guide and checked the answers first. Let's go ahead and get started. The first section is all about using proportions to solve percent problems. In number 1, it says Mrs. O'Connor has a ratio of 2 batches for every 9 people. And we need to know how many batches of banana pudding Mrs. O'Connor needs to make if there's 72 people. So I'm going to set up a proportion. It means I'm going to make an equal fraction out of 72 people. I know that 72 is going to go on the bottom of my new fraction because people was on the bottom of the first fraction. Now I have my proportion set up. I'm going to cross multiply to solve. I circle the two numbers I have across from each other and multiply. In this case, 72 times 2 is 144, and I always divide by that number that's left. So 144 divided by 9 gets me 16. Since the question was asking how many batches does Mrs. O'Connor need, and I got 16 batches, I know I've got my answer and I'm done. Looking at number 2, I've got another proportion already set up for me. So anytime I see two equal fractions like this, missing one part of it, I want to circle the two numbers I have across from each other and multiply. In this case, 28 and 8/10 times 7 got me 201.6. And then I always want to divide by the number that's left. So in this case, 201 and 6/10 divided by 8, which got me 25.2 or 25 and 2/10. Number 3 gives me a rate of 8 rotations for every 15 seconds. I can write that rate as a fraction, 8 times for every 15 seconds. And since I know that that line means divide, I can turn this fraction into a decimal. In this case, the decimal is going to be 0.5 with a repeating 3. Now what I would want to do is go through each one of these multiple choice options and divide out the rate for each one of those and see which one gets me 0.53 repeating. That's just one strategy for doing this problem. You could look at it as a proportion, and you could look for a pattern in the proportion. So for example, in the numerator, to get from 8 to 48, you multiply by 6. If you do that to the bottom, 15 times 6, that gets you to 90. So I know that this one is true. So it's marking it out because I'm looking for the false one. I could also set up a proportion and compare their cross products. When I multiply these numbers across from each other, that should equal these numbers across from each other. In this case, they do. I get 480 both ways. So I can roll out B. And again, just using multiple choice strategies, I know that if it can do 32 times in 1 minute or 60 seconds, I know that it can't do 24 times in 60 seconds because it already did the 32. So I know already that it has to be D. But those are 3 different strategies you could use to solve number 3. Number 4 says there are 60 slices of cheesecake in 5 cheesecakes. That's a ratio of 60 slices for every 5 cheesecakes. And I know I can set up a proportion because it tells me there's the same number of slices in each cheesecake. And I want to know how many there are in 8. I can set up a proportion and cross multiply to solve. So I circle the numbers I have across from each other. In this case, 60 times 8 is 480. And then I always divide by the number that's left. So 480 divided by 5 is 96. Just want to double check that's what the question was asking. Since it says how many slices are in 8 cheesecakes, I found 96 for 8, so I answered the question. Number 5 tells me that a dolphin jumps 54 times for every 6 hours. I know that's a rate or ratio, and I'm going to write an equivalent ratio for every 2 hours. So I'm setting up a proportion, and I'm filling in hours on the bottom because we put hours on the bottom of the first fraction. So as long as it matches, you can do this correctly. When you have this set up like that, you can always cross multiply to solve. So 54 times 2 is what I would do first. I got 108, and then you want to divide by the number that's left. So 108 divided by 6 gets me 18. Since the question says how many jumps would be expected in a 2-hour period, 18 jumps is my final answer. Number 6 tells me there's a package of 12 cans of beans, and it costs $6.84. If it's asking me for the cost per can, I need to put the cost in the numerator or on top of my fraction. Since I want to know how much 1 can costs, I'm looking for the unit rate. I know that that line means divide, so I would do 684 divided by 12. But you could also set up a proportion for every 1 can. Either way, whether you cross multiply or divide, you would end up with 57 cents per every 1 can. Now, the reason we practice setting up proportions is because percent is a type of proportion. Percent is always going to be represented as a number out of 100. So for this first section, we're going to be able to estimate percents. On number 7, it says estimate the following percentages of 60. Now, when you see 60, that is the 100%. That is the total. So there's several different ways we can do these. I'll show you how I would do them, and then I'll show you the shortcut ways. So looking at 10% of 60, I know that 10% is 0.10 or 0.1, because if I move the decimal over 2 places, it ends up in front of the 1. So 0.10 or 0.1 is the same thing as 10%. I know that of means times, and I want to know what 10% of 60 is. So if I multiply that, I would get what 10% of 60 is, which is 6. I think the shortcut way of this is to realize that 10% of 60 is just 6 10 times. You can do the same thing for the 25%. I know that 25% as a decimal is 0.25 because I moved the decimal over 2 places. And I know that of means times. And if I want to know what 25% of 60 is, I can just multiply those numbers. That'll work every time. But I also know that 25% is a quarter or a fourth. And if I'm looking for a fourth of 60, that's the same thing as 60 divided by 4. Those are both strategies to end up at your answer of 15. To find 50% of 60, you could take 0.5 times 60, since of means times. But I also know that 50% is half. So since I'm looking for half of 60, I could just take 60 times 1/2, or 60 divided by 2. Either way, I get 30. And then last one, 20% of 60 is like 0.2 times 60. You could also set up a percent proportion. A percent proportion is always the percent out of 100, because 100 is the max percent. And then the total would go on the bottom of your other fraction, or the whole. So I'm looking for the part, 20%. I would just cross multiply to solve, and I'll end up with this missing number. In this case, I get 12. Number 8 is a visual representation of a percent, looking at it with a percent bar. So in this model, I know that in the bottom, I'm looking at it as a percent, 0 to 100%. So think about your phone battery or your laptop battery. Halfway between 0 and 100 is always going to be that 50%. I know that halfway between 0 and 50 is 25%. And then I know that between 50 and 100 is 75%. It's divided into fourths. So if I'm looking at 100 as the whole, as a percentage, a fourth of that would be each one of these values, just like with money. Now at the top of this model, I have some missing values, but I do have a 70, and I know that 70 is half of the whole thing. But if I just take a second and look at this strip here in blue, if I look at 70 as the whole and I'm looking for half of 70, I know 70 divided by 2 is 35. That's the same thing as saying 25% of our whole. So I still don't have my whole yet. But if you look at the pattern, it's just going up by 35s each time. That's one way to look at this. If you know that 70 is 50%, if you look at the whole thing, you're thinking, what is 70% half of? And that's just like solving a percent proportion like this. In this case, since you're given the part being 70, you would be able to cross multiply this way and then always divide by that number that's left. So in that case, you could realize that the whole bar is worth 140. And if you're going again by 35s, or you're looking at what's between 70 and 140, you should realize that that number is 105. In this next set of questions, we're going to be able to use percent to solve some real world problems. On number 9, it says 15 is 30% of what number? So I'm going to set up a percent proportion. All my percent proportions should look like this. Percent over 100 equals the part out of the whole, or what it is out of what it's out of. So I'm just plugging in the numbers that it gives me into my percent proportion. So the first thing I see is a 30%. That's going to go in the numerator of my percent fraction. So 30 out of 100% equals 15 is the part, because I don't know of what number. I don't know the whole. Now that I've set up my proportion, I cross multiply to solve. 15 times 100 is 1,500, and I want to take that number and divide it by what's left. So divide by 30, which gives me 50. In a problem like this that might seem kind of confusing, you can always double check yourself by taking the 30% of the 50, and if you take 0.3 or 30% times 50, that should give you 15. If it does, you know that you did your problem correctly. Number 10 is a question about a recipe that calls for lemonade and punch. So I know that the lemonade and the punch together makes the total recipe. So I'm going to look for any of these that have a 30 in the denominator, since 24 and 6 make 30. I'm also looking to solve for the percent of lemonade in the recipe. So I know that 6 cups needs to go on top, since that's what the lemonade is. That leaves me with option D. 6 out of 30, being the total, is equal to a percent out of 100. Then I would just cross multiply and solve. On number 11, there's two different ways you can do this. I know that 80% of the 650 students will attend the field trip, so I would do 0.80 times 650, and that'll give you your answer. But you can also set up a percent proportion. In this case, I know that 80% is attending out of 100 total. Percent's always out of 100, so that's my first fraction. And then my second fraction tells me that the 650 is the total, so it goes on the bottom. Then I can cross multiply to solve. So I circle the numbers across from each other and multiply, divided by the number that was left, and I got 520. Since the question was asking how many students attend the field trip, my answer would be 520 students attend the field trip. Number 12 can be a little bit confusing, so pay attention to which thing you're solving for. I see a percent, and the question's asking me for a number of items out of a total, so I know I'm going to set up a percent proportion. In this case, there's 3% out of a total 100%, and then I want to set up my equivalent fraction. Since the number of defective items is out of 300, I know 300 is going to be at the bottom or denominator of my second fraction, and I'm solving for x here. After cross multiplying and dividing by the number that's left, I got x equals 9. Now I just found the 3% that are defective. I found 3% defective. That means that 9 out of the 100 don't work. Since the question's asking how many of the items worked, I know I'm going to need to take my total 300, take away the 9 defective, and I'm left with 291 working items. The next section is some more real-life percent problems. In number 13, I'm looking for a percent increase. I'm looking for percent change. I know there's a formula for that. It's percent over 100 equals the change over the original. It doesn't tell me the percent. I'm solving for that. But I know the percent's always out of 100. So my first fraction is going to be x out of 100 equals the change. Now the change in a math problem like this is going to be the difference. So 2,800 or 2,800 minus 2,000. The difference between those numbers is 800. I subtracted out of the original. What did it start with? It started at 2,000 because that's the number that was listed first. It said it was from 2,000. So I know that when I have my proportion set up like this, I can always circle the numbers across from each other and multiply and then divide by the number that's left. When I do that, I get a 40. Since the question said, by what percent did the number of calories increase? And I just found the part of my fraction that's the percent. This is a 40% increase. The wording on number 14 is a little confusing, so bear with me. Any order that's over $250 has this $35 shipping and handling fee included. So this $437.50 already includes the $35. The question is asking me for what percent the shipping and handling fee is out of the total. So when I set up my percent proportion, my second fraction is going to be the shipping and handling fee out of the total. And that total, like I said, includes the shipping and handling fee, even though I know it doesn't explicitly say that in the word problem. Then I would cross multiply and divide by what's left to solve. I got 8, and the question said by what percent, so I know I just found 8% the shipping handling fee is of the total. 15, like 13, is a question about percent change, and you have a formula for percent change. It's percent out of 100 equals the change of the original. Since I'm solving for the percent, my first fraction, I'm going to write as x out of 100 equals the change, which in this case is the difference between how many enrolled at the beginning of the year versus how many they had at the end of the year. The difference between those two numbers is 24. I always subtract to find the change. The denominator or the bottom number of this second ratio is going to be the original. Since it started the year at 480, that would be the bottom number. Then I always cross multiply to solve. So 24 times 100 and then divide by the 480. When I do that, I get a 5. Since the question asked me by what percent did we change, it's a 5%, and since it went from 480 to 504, this is a percent increase. There are a few different ways to do number 16. It says there's a markdown, or it was marked 30% off, and that's a type of discount. So one way you can do this is to take the total, 56, and since I'm looking for 30% off, I first need to find what 30% of the 56 is. So I'm going to multiply by 30% as a decimal. That's 0.3. When I do that, I get 16.8 or $16.80. That is my discount since it's marked 30% off. I found 30% of the total 56 and I got $16.80. Like I said, it's marked off. That means I can subtract that from the total and I get my final total price of $39.20. That's how much the sweater is on sale for. If you didn't like that method, you could also set up a percent proportion. On the answer key, it says 70 out of 100 equals X out of 56. That's because they've jumped one step ahead and said if it's marked 30% off, that's the discount. The sale price will be 70% because 70 and 30 make 100. If that makes sense to you, do it like that. You could also set up and solve for your discount like this, and you would cross multiply to get that, and then you still have to do that second step of subtracting it off. Do whatever works for you. Whichever one of those ways works for you, keep that in mind and do that. Number 17 is a proportions question, and it is just a little bit confusing because there's a few steps that they don't do for you. So just like the last one, percent is always out of 100. It tells me there's 35% of some cream-filled danishes out of the 100%. Percent's always out of 100. Now, the thing it doesn't tell you is the total. It actually makes it kind of confusing when it says there's 4 trays with 18 danishes on each tray. So you have to do a little bit of work to figure out what the total is. In this case, I know that each means times, and if there's 4 trays with 18 danishes on each, I can do 4 times 18 and get 72. That means there's 42 danishes in total. And the question is asking me for how many contain cream. I know that's 35%, so that's going to be at the top. When I have a proportion set up like this, I can cross multiply to solve, and I always divide by that number that's left. When I do that, I end up with about 25. I actually get 25.2. Since it says it's approximate, we're going to just round to 25. 18 is a multi-step problem. I'll do the first part in purple. It says on Monday, Jeff bought a shirt for 40% off of the regular price of $16, not including tax. So the first thing we want to do is figure out how much Jeff bought the shirt for. So I take the whole 16, and I need to find 40% of that number. So I'm going to always multiply by that number as a decimal. So 0.4 is 40%. When I do that, I find that there is a $6.40 discount on the shirt. Since it was $16 and I'm taking off $6.40, the final price that he paid on Monday was $9.60. The next part of the problem I'll do in orange. It says the next day the t-shirt that he bought was marked down 75% off the regular price. The regular price was $16. So the first thing I'm going to do now is find 75% of the $16. I'm finding that so I can subtract. So the next day's markdown was $12 or a discount of $12, which means that I need to take that off of the 16 original. That means that the next day it was $4. And the question says, finally, how much would Jeff have saved if he had waited until Tuesday to buy the shirt? In other words, what's the difference between these two prices? When you take $9.60 minus the $4 it would have been, that means that he would have saved a total of $5.60. For percent error, I'm going to use the formula percent out of 100 equals the error out of the exact. It's just like percent change. I'm going to start by finding the difference between these two numbers. So I'm going to take 524.5 minus 480, and I'm going to get 44.50. That's the error that they were off by at the hospital. So $44.50 out of the exact. Since it actually costs $524.50, that's going to be the denominator or the exact amount. And again, I'm solving for the percent. So that's going to be set up like this, and then I cross multiply and divide to solve. When I do that, I end up with 8.5. So there's an 8.5% error. Using that same formula, I'm solving for the percent out of 100, and I know that he was off by 2 minutes because 28 minus 26 is 2. And that's over the exact time, which was 26, because it says his actual time was 26. And then just like the last one, I cross multiply and divide to solve. When I do that, I get 7.7%. Let's look at these simple interest problems. In the next problems, we're going to use the formula for simple interest. Interest equals principal times the rate times the time. So look at the problem and I see what I have. She starts at $5,000 as her investment. That's the principal. That means that that's the starting point. I know the rate is 2%, and I want to know what that rate is as a decimal. So I take the decimal and move it over 2 times back. So 0.02 is the rate, and the time is in years. Since there's 3 years, I know that I can put in 3 for the t. To find the interest, all I do is multiply these values, and I end up with a total interest of $300. Since the question's asking what the investment will be worth altogether, I'm going to take the $5,000 principal plus the $300 in interest and add those together to end up with a final total of $5,300 for her investment. 22 is also a question about simple interest, so I use the formula interest equals principal times the rate times the time. When I look at the problem, I'm going to pull out the information that I have. In this case, she borrows $2,000 to start. That's the principal because she started out by borrowing that money, so I'll put a $2,000 in for the P. She pays 8% interest. That's the rate, and I know that I need the rate as a decimal, so 0.08 is the decimal equivalent of 8%. And I know that it's over a period of 18 months. And I want the time in years. So 12 months makes one whole year. And since there's still 6 months left, that's half of a year. So 1.5 or 1.5 would be my time. To find the interest, I need to multiply these values together. And when I do that, I find that the interest is $240. And in the question, it's just asking me how much Jamie pays in interest. It's not asking me for the total. So this will be my final answer for this question. All right, guys, that's it. If you have any questions, please let me know. And good luck on your test. Bye.